Let's move to the next, which is the voltage drop. So voltage drop in a wire are a function of three parameters. So conductor, cross-section area, length of wire, and current flow in the wire. So voltage drop in cable due to resistance is a result of power loss in the cable. Okay, that's why voltage drop happen. Okay, excessively long cable can result in loss of power to the inverter and lower system efficiency. It means that the longer cable you have, the higher loss of power that you will obtain. Okay, so based on the MS 1837 2010, the cables from the solar array should be selected so that the voltage drop is less than 5%. Okay, the key point here is the 5%. So same like before. So we are putting aside the part for the AC. So we're focusing only for the DC since we are playing with the PV. Okay, the equation is simpler than before, but the difference on the bottom part, while the upper part is still remain the same, which is 2 multiplied with IDC cable, multiplied with IDC, multiplied with rho, but the bottom part will be changed from the loss multiplied with MP3 to the ADC cable, which is the cable size. So, like for example, from the previous example 5, so we get 2.5, so that 2.5 value will be replaced here, right? Okay, let's try with the example 6. So almost the similar question, but different. So a PV string comprises of 7 modules, same module, which module produces 5.35 amps and 19.7 volt for current and voltage respectively. Okay, still the same. So the distance between the PV string and combiner box here is 25 meters. Okay, different. Example 5 10, now 25 meters. So if 2.5 millimeter cable outside is selected, I think refer to the maybe almost the same question with the example 5. 2.5 is selected. Estimate the possible voltage drop. Okay. Assume the resistivity of copper wire is 0.017857. Right. So here, so we just take out the equation. So we just put the value bottom at the bottom one is 2.5, and the length cable here is changed from the 10 to 25. Then we get the answer of very simple 1.9107 volts. But since here they're asking you what possible voltage drop in percentage, so how to calculate the percentage? But so it's very easy. V drop DC percentage equal to V drop DC here over the VMP string. So the VMP string is still applicable here, and multiplied with 100 means, which means that VMP string is equal to 119.7 multiplied with 7 here. So you get this value over this value, then you get 1.3856%, which is lesser than 5%, the maximum allowable voltage drop. Okay, based on the MS 1837 2010. So the answer here is almost 1.5% for the voltage drop. Okay, for the example 6. Okay, move to the next. The last part is the power loss. So the power loss typical modus of string cable 1.5 and T6. Then based on the standard 2.5 is the same. Okay, once the cable selected, actual voltage drop or power loss can be calculated. So the difference to the voltage drop is only at this part only. So the IDC one is 2 times here. Okay, so IDC multiplied with another one IDC, then you get the answer already. It's very simple, no different. As usual, we are putting aside the SC part. Okay, we focus on the DC. And that's why, for example 7, I think yes, the question is still the same, no different with example 6, but the difference only the equation here where the IDC is multiplied with IDC again. So here, then you get the answer of 10.2222 watt. So this is the final answer for the power loss. Okay, power loss. Alright, last but not least, for the PV system performance. Okay, we are going to the last process to evaluate the expected performance of our system. So if the system designer job to provide an estimate of energy yield, the system can provide. This information may be provided as an energy yield or as the available solar radiation. Thus, whether through the year it can be provided as a monthly yield. So PV energy yield can be calculated. So the first item of the system performance is the energy yield. We have learned already. So at the time we are given the question, they are given you the energy yield, then you find the number, the end total, for example. But in this part also, energy yield is a part of the system performance. So the E system is the same equation as before, right? Then the next two items is specific yield. Specific yield is the E system energy yield over the rated power of the array. So which is we call it as P array STC. You still remember what is the P array STC? Array power at STC. For example, we have 10 modules. Regardless connected in series or parallel, but in total we have 10 modules. So each module we get 100 watt, for example. So 10 modules means 1000 watt. So that is the P array STC, for example. Okay, next is the performance ratio. So performance ratio is simplified as SPR. So E system over E ideal. Okay, what is E ideal? That is ideal energy output from the PV array at STC. Okay. Okay, finally, we have reached to the last example for this chapter, gate connected PV system, that will cover the exercise for PV system performance. So, example 8. Okay, let's go directly to the questions. So, moment promise moment. What's the moment? I'm not sure. Is it any from created from movies? I'm not sure. I just replicate it, but never mind. It's okay. He promises his client that if his design, I thought she, but it's okay. Nobody cares. His design proposal of a 7 kilowatt PV system is receiving enough annual radiation of 1,500 hours. This system is expected to yield at least 8,600 kilowatt hour of energy. So based on this claim, estimate the specific yield and performance ratio for the system. So here we get the value of 7 kilowatt. 7 kilowatt, what is the value for this? Is the value for P array STC. So the key point here is watt and PV system. So 7 kilowatt PV system is the P array STC. Next is annual irradiation of 1526 hours. Means that if you still remember, we got it as PSHPA, it's an hours per annual, 1526 hours. So this is expected to yield at least 8,700 kilowatt of energy. So clearly it is energy yield or E system. So simple. Okay. You just have to calculate the specific yield and performance ratio. I promise you, we're going to add it shortly. Okay. Right, simple equation. Just put the substitute the value of the system 8,700 kilowatt hour over 7 kilowatt peak. Then you get the answer of specific yield 122815714 kilowatt hour over kilowatt peak. Remember, this is the form how to write the final answer for the specific yield. The value will be in kilowatt hour over kilowatt peak. Okay. Okay, next, PR ratio is the E system over E ideal. So E ideal was that? E ideal equal to P array STC multiplied PSHPA. So that's why you get 8,100 here, then 7 kilowatt here, then you get 1526, and your final answer will be 0.8051 or 80.51%. Okay. Okay, thank you. Finally, we've finished the whole chapter of the grid connected PV system. So I hope you can understand it well. If you still don't understand, you can repeat it many times, or you can directly WhatsApp me or email me, contact me for any question. Alright? Okay, thank you.